Good. Hello. So my name is Markus Oberlehner, and my topic today is monorepos. So we're going to look at how you can use monorepos, what they are, and how I converted one of my own personal projects from using many repos into one single monorepo. So, but first of all, a little bit more about myself. I'm a web developer at karriere.at. In my free time, I'm working on a lot of open source projects. You can check them out at GitHub. Two of my favorite projects are Node.js Magic Importer, which is a tool that makes it possible to import specific SES selectors from a SES file instead of the whole file, and Avalanche, which is a modular SES framework. We're going to see a little bit more about Avalanche a little later. I actually started to use monorepos with Avalanche. So a few months ago, I also started blogging about web development and life in general. So first of all, let's start with the question, what actually is a monorepo? So very broadly speaking, a monorepo is a single repository containing the code of multiple projects. So those projects may be related, but they also can be completely unrelated. One example for a project consisting of related projects would be React, for example. So React is maintained using a monorepo, and it contains the core functionality, which is React Core, and for example, components like React DOM, which depends on the React Core package. So let's take a look at some examples how monorepos could look like. One example would be the code for a website from multiple apps, so for an Android, an iOS app, for example, and an API, which is powering both the website and the apps, all contained in one single repository. So 3 different but related projects are all maintained in one single repository. Another example could be all the code or assets in general of a company is contained in one single repository. So basically every line of code that is written inside a company, so for their internal services, for their software products, for example, is contained in one single repository. And the third example could be the core functionality of a project and multiple related components are all contained in one single repository. So basically, the JavaScript framework React or the PHP framework Symphony using such an approach. So some of you might ask yourself, isn't that actually a horrible idea to maintain all of your code in one huge code base, in one huge repository? And actually the answer is not necessarily if you are doing it right. So if we take a look at modern-day software development, all is about package managers, microservices, and so basically modularization in general. So, and this is a very good thing because reusing code is very valuable, and you don't want to reinvent the wheel again and again. But it's important to note that using a monolithic approach for maintaining your repository doesn't actually mean that you should write tightly coupled code or monolithic software in general. So, for example, there are many modular open source projects which are using monorepos, and also many microservices-based infrastructures are built using a single repository approach. So basically, it's possible to combine the best of 2 worlds. Modular code is easier to share and to reuse, and code maintained in one single repository is generally easier to maintain and can be a lot easier to refactor. So monolithic source control doesn't mean tightly coupled code, quite the opposite. So if you're effectively using a monorepo approach for maintaining all of your projects, you can have both a modular code base and a very easy maintainable code base. But like most development techniques, of course, monorepos aren't perfect either. So let's take a look at some pros and cons. of using a single repository approach. So start with the downsides. With an increasing size of your code base, also complexity grows usually. So it's easier to understand smaller pieces of code in separate packages than it is to understand one huge code base, especially if a new developer is coming into your team. It might be very overwhelming to have a huge repository containing all of the code of your company. Also, there can be potential scaling problems. So with version control systems like Git, for example, Git is known to become slower the bigger your repository grows. So this can be a problem. Things like access control, for example, which are very easy to implement when you're using multiple repositories, can be harder too when you're using just one monorepo. So it's very easier to restrict the access to a certain repository to certain peoples. But depending on the system you're using, this can be impossible or very hard to implement when using a monorepo approach. Also, with a growing code base, there is the potential for build and test bloat. So if it's not possible to test separate chunks of your code base, tests and building can take a very long time. But on the upside, there's one source of truth, for example. So every employee of your company or every contributor of an open source project is always on the same page and works on the same code base. Also, extensive code sharing and reusing is possible. So this can be a bad thing too if you are doing it poorly and you start to coupling your code. But usually, reusing a lot of code is a good thing to do, and it's much easier using a monorepo approach. Also, large-scale refactoring. So imagine you're changing an API which affects multiple projects you are maintaining. When you're using a monorepo approach, this could be done with one commit or at least one merge request instead of having to change the same API endpoints across all of your projects again and again and make separate commits for every change, affecting maybe hundreds of projects if you're a large company. So another huge upside is collaboration across teams can be very easy. So imagine there is a bug in your code base affecting multiple of your projects. When you're using a monorepo approach, this bug could be fixed by one team or even one team member instead of having to wait on all of the other teams working on the other projects to fix the same bug in their code base until you can deploy. Okay, because there are two variant use cases of how monorepos could be used, I differentiate between two basic types of monorepos. So the first type I call monstrous monorepos because of their monstrous size they can grow to. And the second type I call project monorepos. So, but first of all, the monstrous monorepos, how would I define that? For example, all the code of a company, so all the code for all of the software projects and all the code for all their internal services. So basically every line of code that is written in a company is stored in one single huge repository. So popular examples of companies which are using this approach are Twitter. Twitter is using a forked version of Git with multiple patches to improve the performance when working with very big repositories. And they have a repository which is several gigabytes in size. Facebook, on the other hand, has decided to use Mercurial. And they are constantly working on improving Mercurial to work well with very big repositories. So this is a huge challenge to really manage very big repositories with the existing systems. And the Facebook repository is over 50 gigabytes in size. And these are pretty old numbers, so I'm quite sure this is now a lot bigger even. And if you thought monstrous is a little over the top as a term to describe a monorepo, let me tell you about Google. So Google is using a custom source control system called Piper and clients in the cloud to handle a 90 terabyte repository. So basically every line of code and every commit ever made the last 18 years approximately of Google history is contained in one truly monstrous repository. The second type I would call project monorepos. So project monorepos are quite different to the first type of monorepos. They are very popular among open source projects. So many open source projects consist of a core functionality and multiple components which extend the core functionality but are optional. So those components managed in the monorepo, they might depend on other components in the monorepo, but they can also be completely independent. So there are multiple projects using either components which depend on each other or could also be completely independent. So examples of projects which are using this approach are the JavaScript framework React, the JavaScript compiler Babel, another JavaScript framework Ember, and the PHP framework Symphony, and a lot of other open source projects are using a similar approach. So let's take a closer look at such a project which is using a monorepo approach. Babel is an example for a fairly large-sized project monorepo. So they're using a single repository approach to manage more than 100 components which are located in one single repository. They're using a tool called Lerna. We're going to see a little more about Lerna a few slides later. And Lerna is especially great in managing multi-package monorepos. Also, sorry. So multi-package, I mean especially NPM package. So Lerna is a tool for managing NPM packages. This was a German slip before. They're using fixed versioning. What this means is that every one of those 100 packages or components they are maintaining in their repository has always the same version number. So if they are changing something in one of the components, all of the components get the latest version number. So this is especially great because you always know that every components work at this version number work together very well. So what we can see here is a simplified file tree of the Babel project. We can see at the top there is a lerna.json file. This is the configuration file for the Lerna tool. There is a library directory. So this is one upside of using a monorepo approach. You can reuse library code across all of your projects managed in the repository. Then there is a package.json file, which is a configuration file for NPM package manager. And then there is the packages directory. So the packages directory contains all of the more than 100 packages which are contained in the Babel monorepo. And we can see how those packages look with the example of the Babel preset ES 2015 package. So every package contains its own package.json configuration file for the NPM package manager and has test files and source files and so on, and README. Then we can see the scripts directory containing, for example, the test shell script. And again, we can see we can reuse one test boilerplate script to test all of our packages instead of having to repeat the same test code over all of the 100 packages again and again, which would be too much overhead to do. OK, so another very famous open source project which is using a monorepo approach is Symphony. So Symphony is one of the most popular PHP frameworks currently. It consists of about 30 components, which are all maintained in one single repository. So Symphony, very interestingly, is using a combination of monorepo and a many repos approach. So every time they are making a commit to one of their components managed in the monorepo, a tool called split.sh will generate and update separate read-only repositories for every one of those components maintained in the monorepo. So one reason why they are doing this that way is because Packagist, the most popular PHP package repository, is requiring every package to have its own repository, its own Git repository. So because of that, they are creating automatically separate repositories for every component maintained in their monorepo. Okay, now we're going to look at how I converted one of my own projects from using many repos to one, or actually two repositories, so one monorepo and the second. So the project is Avalanche. Avalanche is a modular SaaS framework. Modular means that every one of its features is stored in its own repository. So for example, the CSS grid has its own repository, or things like button styles have their own repository. So basically every feature of the framework has its own repository. So I had about 40 components which all had their own repositories, so 40 NPM packages and 40 Git repositories. And I wanted to do a major refactoring. So basically I wanted to change things like naming conventions and other CSS style linting rules and such things. So I very quickly realized this would be a lot of overhead to do, because for every major change, I had to make 40 commits across 40 repositories, which were always basically the same. So changing the naming convention, which would much better fit in just one commit across all projects. So I quickly realized this was not the right way to move on, because also tooling like linting, testing, and all of this had to be repeated again and again and again over all of the 40 repositories. So if I wanted to change a linting rule, I had to change the same linting rule across 40 linting configuration files across 40 repositories. So this was not the right way to move on. I started with a basic structure like you can see on the left. So I had 40 repositories, or 42 repositories, and after moving to a monorepo approach, I ended up with two repositories. So one is the main repository for the framework and all of its components, and the second one is basically a static website generator. So I could have moved the website generator into the core monorepo too, but I decided against it. I don't know why anymore, but it would have been a viable option to do it the other way too. So this is a basic file tree of the Avalanche repository. You can see it looks pretty similar to the Babel project. We again have a Lerna.json configuration file at the top. We're going to see what this looks like in one of the next slides. We have a package.json configuration file again for the NPM package manager, and the package directory containing all of the features of the framework. So things like the grid, container styles, and so on. And again, there is one test directory containing all of the test boilerplate code. So if I can run test.sh to test all of the packages at once, or I can test one package after another. Or you could even configure it to that your build tool runs the tests only for those packages which have changed. So now we are going to take a look at Lerna. Lerna is a tool which makes it much easier to handle large-scale multi-package monorepos. So Lerna was actually invented by the people behind the Babel project, because they needed a way to make it easier to handle their more than 100 packages contained in their monorepo. So the best way to get started with Lerna is to install it globally. It's an NPM package, and then you can run Lerna init. So what Lerna init does, it creates the basic directory structure, and it will create the Lerna.json file we have seen before, which looks something like you can see at the top. So the version number of the Lerna tool is set, and then you have the version key defining the versioning method. So by default, Lerna is using fixed versioning. So whenever you are changing one of your packages, all of the packages will get a new release and will get a new version number. But you can also change this to independent versioning. So with independent versioning, you can update only those packages you actually have changed. So one problem with this approach could be that you end up with different major versions. So you might, if you're making something like a framework, you might want to have one major version for all of the packages that you always know those packages work together very well. With independent versioning, you could end up with a 4.0 major version and multiple 5.0 and 6.0 and so on. So yeah, it's a matter of taste. Or it also depends on if your packages are all very independent. So if you have a framework containing many independent projects, independent versioning might be also a better fit for you. You can also change the default packages directory. It's by default, it's just packages. OK, so when I decided that I wanted to move to a monorepo approach, I didn't want to lose all of my commit history. So luckily, Lerna provides a tool for that. You can use Lana Import to import existing repositories into your new monorepo. And it will keep the commit history. And it's also very smart about it, so it will change the paths referenced in your commits. So it basically will look like the imported repository was always a part, or has been always a part of the monorepo. OK, so after adding some packages and after importing some packages, you can run Lerna Bootstrap. What Lerna Bootstrap does, it looks into all of your packages in the packages directory and resolve their dependencies. So, and it's also very smart about it. So if you are having cross dependencies, so one of your packages depends on another one of your packages, it will actually create a symlink. So during development, it's very convenient to have a symlink across your dependencies. So now after you're ready to go and you want to make a new publish of your changed package, you can run Lerna publish. And depending if you are using fixed versioning or independent versioning, it will publish a new release of all of your packages, or with independent versioning, you can choose the package you want to update and create a new release. And the release will publish to NPM, the NPM package manager. OK, so it's time for a quick recap. Monolithic source control doesn't mean monolithic software. So you can build modular software using a single repository approach. And many successful companies and projects are using this. There are two types of monorepos. So one type of very huge monorepos containing multiple different projects used by companies like Twitter and Facebook and so on. And there are tools which can help you maintain your monorepo. So for example, SplitSH, which can automatically generate separate repositories of your packages maintained in your monorepo. And there's Lerna, which can help you to manage multi-package monorepo with NPM packages. So thank you. This was my short introduction into monorepos and Lerna. I hope you liked it. Thank you very much.
Thanks, Markus. Now we have time for another Q&A session. So are there any questions? Just raise your hand. Here is one. The mic is coming in a few seconds. Please wait. Bum, 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 bum. It's here.
Hi, so first of all, thanks for the interesting talk. You briefly mentioned the problem of access control and permissions. So can you elaborate a little bit about this?
Yeah, it's actually a problem that's not really solved in the common version control systems. Google, for example, has this implemented in their custom system, and this is was one reason why they have their own custom system. So with Git and Mercurial, it's not really possible with the tools itself. So you have to implement something like yourself. So yeah, there's not really a ready-to-use solution I'm aware of.
Okay, thanks.
Another question? Please just raise your hand. Here.
The Lana Import command, is it coupled to some specific version control systems?
Yeah, to Git.
Okay.
More questions? Yeah. Just please wait for the mic.
Do you know if those tools also work for other languages? Or is it only environments? Is it only JavaScript and NPM, or is
SplitSH works independently, so it works with Git basically, and Lerna is only for NPM packages.
Okay, thanks.
Another question? Here.
This is not my question, it's actually a question asked in the app. So it says, did you try also to use Git submodules or subtrees before moving to Monorepo approach?
I personally didn't use submodules, but we used them at our company. And they were the reason for a lot of pain. So I have not the most of knowledge about submodules, but the one I have is a lot of pain.
Well, I would say that's it.
Thank you.
Thanks for this talk.